Welcome to MRU E-Learning powered by Malla Reddy University. My name is Nagamali Kacha, working as assistant professor in Malla Reddy University. Today, I am teaching about computer architecture pipelining. So in the computer organization and architecture, we have the different kind of mechanisms. Out of all that, one of the important topic is parallel computing pipelining concept. So in the pipelining, we are going to be discuss how the instructions are going to be executed by the processor. This is the topic today I am going to deliver. So first, the complete structure of this lecture is introduction, need for the pipelining workflow, pipelining stages, generic four-stage pipeline, examples and advantages of the pipelining and disadvantages of the pipelining. Finally, we can conclusion. So first, introduction. What is the pipelining? Pipelining is a technique to execution of the instructions in parallel approach. Different kind of the instructions are overlapped manner execution will be happens. This kind of the thing we can call concurrent execution of the instructions. This technique is widely used nowadays in the all kind of the multiple processors, because not only about a single processor. So with the having of the combination of the multiple processors, it is to be working and giving the results at a time. Need for the pipelining. Actually, to enhance the processor utilization. To enhance the processor utilization, it will happens with the help of the two methods. The first one is by addition of the different kind of the hardware circuits. So this is one concept, because everyone wants to improve the system performance. Everyone expects the system performance. So for getting of the good system performance, we always go with these kind of the options. The first one is attachment of the new hardware circuits. So if you give the more number of the circuits to this processor, it will give the results very quickly and very fastly. That is one approach, but it is very costly and very timely taking process. To avoid that and to use the present existed process only effectively, we can have the very good important concept that is known as pipelining. So with the help of this pipelining, we can do the different kind of the operations at a single unit of the time, so that the pipelining is very helpful, very useful for processing of the programs in the computer. So as well as in this prospective utilization of the hardware resources happens and will gives you more number of the results simultaneously. How it is going to be work? So in the computer level, in the computer programming, so many kind of the programs are going to be executed for our requirement. So if you consider one program, it is a combination of so many instructions. Each instruction is going to be executed by the processor. So actually in the initial level, each instruction is executing one by one. So that is we can call sequential manner of execution instructions. This is next level approach, that is we can have parallelism, parallel computing approach, that is we can call instruction pipelining process. So with the help of this instruction pipeline, we are executing the multiple number of the instructions at a single unit of the time. So this is entirely happening in the computer architecture only. So how it is to be happen? Each and every instruction execution can be execution can be divided into the different group of the segments. Each segment can perform some kind of the operation. So while working of the one operation, one instruction process, At the same time, second instruction will coming into the processor memory, and it will decode the some kind of the operation. So how we can decide all these things? We can call it as different stages. So right now I am going to discuss about how these pipeline stages are working. So if you see one pipelining structure, in the pipelining structure, it is derived from the instruction life cycle. Actually, the parallelism is derived. The instruction parallelism is derived from this instruction life cycle only. So what it contains? The instruction life cycle contains in initial level, we are fetching of the instructions. The second one is decoding of the instruction. Third one, execution of the instruction. And finally, fourth one is the write back. So these combination of four operations, it will gives you the instruction life cycle. So in this diagram itself also, you can observe the start and fetch the instruction and execution of the instruction. And once while executing of the one instruction, it will going back to for the second instruction. So it means while executing of the first instruction, it is going for the fetching of the second instruction I2, so that it came back to fetch the instruction. So it means while executing of the one instruction, the second instruction is going to be fetching. So it means parallelly two kind of the works are going to be happen here. So finally, in this CPU, the instruction starting and ending. So starting of the instruction execution, fetching of the instruction and finally execution of the instruction, and whatever the executed the output, it will store into back to the memory. So this is actual procedure will be happen. So how these pipeline stages are came into the picture from the 1950s onwards. Initially, we have the one human machine only. So in the one human machine, it is the computer initial days, only one stage pipelining is used. It means a sequential manner only. If you are executing the one instruction, means you are fetching the particular instruction. After completion of the task, you are decoding of the instruction. Once completion of the decoding, you are going to be execution. So and after that, it is going to write back the result to the memory. So in this sequence, there is no any kind of parallelism. There is no any kind of parallel execution of the instructions. So after that, what will happen? The number of stages are increased based on the computer architecture development. So later on, the computer organization, the computer architecture developed with different aspects. So we have the availability of the different number of the pipelining stages. So the completely computer architecture based only, this pipelining is derived. Some kind of the computers like PAC microcontroller will have the two-stage pipeline, and IBM, what it has to done the research in the 1956 onwards, the stretch project initiated by the IBM, it is given the compulsory of the three common stages. What are the three common stages? Instruction fetching, decode, and execution. These three stages compulsory in all kind of pipelinings. So starts with the three, and later on based on the processor developed computer architecture advancements, we can have so many kind of advanced pipelines like many processors nowadays like Intel Pentium 4 onwards. Some processors are using pipelining with 7 stages. Some processors are using pipelining with 10 stages, pipelining with 20 stages. And as well as nowadays, most popular pipeline is RISC pipeline. It has the 5 stages. RISC pipeline, nowadays all kind of the computers we are observing multiprocessor architecture. So RISC pipeline, it has the 5 stages. What is the 5 stages? Actually, previously what we observed, instruction fetching, decode, and execution, and write back. With the combination of these 4, one more stage is attached here in this RISC pipeline. So that is memory stage. So, and as well as one more very frequently used pipeline, generic pipeline. So it has 4 stages. So this is only will take the example for the explanation perspective and teaching perspective for the student understanding ability perspective. And we are going to discuss about the generic pipeline. It has the 4 stages. So right now I am showing this diagram which has the 4-stage pipeline. Observe here, these are the register 1. In this diagram, if you check instruction fetch, while fetching of the first instruction, whatever the result, it will store into the interface registers. That is, in between of these different stages, the interface registers are going to be established. So the results are going to be stored into these interface registers. These interface register will send the output to the next stage. So observe here instruction fetch stage is there, and decode phase is there, instruction execution phase is there, as well as instruction after completion of the execution write back. So what is the write back procedure? Whatever the result we got, it will store into the memory only. So directly, so initially whenever you are fetching of the instruction, it will come from the memory itself only. It is not like a CPU, it is not like stored in the CPU. First for the fetching of the instruction, we are taking that from the memory. We are taking that particular program, particular instruction from the memory, we are storing into the CPU, and we'll take the instruction by instruction execution and by applying of this pipelining, and then finally whatever the result we got, it will store back into the memory itself only. So this is the 4-stage pipeline which we have, generic 4-stage pipeline. So here we are going to discuss with this generic 4-stage pipeline with the 2 instructions execution only. So I have the one program, and within that particular program I have the 2 instructions, instruction 1 and instruction 2. The instruction 1 is representing R1 is equal to R2 plus R3. Instruction 2 is representing R4 is equal to R1 plus R5. So that so addition of the 2 values and stores into one particular register, and after that again one more addition which required the input from the previous instruction result itself only. So this kind of the thing I considered here. So here how we decoded applied this instruction pipelining, observe here. So see, I am taking one kind of the diagram. Actually it was displayed on the diagram. Again I am going to take like this. So 2 instructions. This is, we can have clock cycles of the time. The time we can represent with the clock cycles. And this is stages. Instruction fetch phase, this is decoding phase, this is execution stage, and this is write back stage. These are all the different stages, 4 stages. So first what I am doing, I am taking the instruction which is in the instruction fetch phase, and this is in the first clock cycles of the time. And after reaching to the second clock cycles of time, the instruction 1 will reach to the decoding phase. At the same point of time, at the same clock cycles of the time, instruction 2 will enter into the instruction fetching phase. See here. So 2 instructions are kind of the operations are performing simultaneously. So concurrently execution of the 2 instructions, different process blocks. And next, while coming to the third clock cycles of the time, the instruction 1 will reach to execution phase, the instruction 2 will come to the decoding phase, and while coming to the 4th clock cycles of the time, instruction 1 will come to the, once the execution happens, it will come to the write back. So write back means the output is generated, the instruction 1 is executed and stored into the memory, everything is completed in the 4th clock cycles of time. In the 4th clock cycle time, instruction 2 is coming to the execution phase, and next instruction in the 5th clock cycle time, instruction 2 will come to the write back. So the 2 instructions are executed with 4 stages in 5 clock cycles of the time. So this is the parallelism. So I explained with these two instructions only. Observe here. So here with these 2 instructions, how much of the clock cycles of the time it is taken? Observe here, it is taken 5 clock cycles of the time. So total with the 5 clock cycles of time. For example, if you go with the non-pipelining concept, non-pipelining means sequential. Non-pipelining means how much time it is going to take. So 2 instructions, and each instruction can go with the 4 stages. 4 stages means instruction fetch, instruction decode, execution and write back. So 4 multiplication with 2, we can get the 8 cycles time. But while going with this pipelining, how many cycles we finished? Within 5 cycles. So within 5 cycles means the time is reduced. So we have the good result with the using of this pipelining. And what is the formula we can go with this? The k plus n minus 1. How we can get this? K is the number of stages. Actually here we implemented with the 4 stages. 4 stages means 4. N minus 1 is how many number of instructions. So here I used the 2 instructions. 2 minus 1 is equal to 1. So 4 plus 1 is equal to 5. This is the 5 cycles of the time. So now I am going to be explained with the this time diagram with the for the 5 instructions. This is the 5 instructions. So instruction 1, instruction 2, instruction 3, instruction 4, instruction 5. These are all instructions are executing in 8 clock cycles of time. For example, here also I am going to be go with the stages of the 4 only. 4. So k plus n minus 1. K plus n minus 1, another example. So k plus 1, k plus n minus 1. So total how many number of stages we have here? 4 stages. 4 stages, and how many number of instructions we consider here? 5 instructions. 5 minus 1. So 4 plus 4 is equal to 8 clock cycles. Observe here. This is the 8 clock cycles of the time. Actually, if you go with the non-pipelining, how much time is this going to take? Each 5 instructions multiplication with 4. 5 instructions. Each instruction will go with the 4 stages, right? So 5 fours 20 clock cycles of the time. But we are avoiding this 20 clock cycle of time, and we are getting the 8 clock cycles only execution is completed. This is another example. And next, while we are going to be compare with the non-pipelining and pipelining within the diagrammatic representation. Observe here. This is the pipeline, what I told: fetching, decode, execution, write back. So this is the clock cycles of the time, and these are the instruction. First instruction came to the picture. This is the pipelining concept. First we go with the non-pipelining. Observe here. This is the clock cycle of time. So first instruction should go with the fetching, go for the decoding, and then the execution, and then write back. So while doing of this entire scenario, we are not touching any other instruction. We are not executing any other instruction I2. But after completion of then only we are going to the another instruction. So for executing of these are all the instructions, it taken 8 clock cycles of time. While going the pipelining concept, so observe here. First instruction fetching, second instruction whenever reach to the decoding phase, immediately the second instruction is coming to the picture for the fetching. The second instruction, whenever the first instruction went to the execution phase, instruction 2 is like this. So the speed up, how we can calculate for this, we can have the total clock cycles of the time, well how much we are using in the pipelining, in the non-pipelining, by how many clock cycles of the time we are using in the pipelining. So first observe here, in the without having of the pipelining concept, we are used 8 clock cycles of the time, but with the pipeline we go with the 5 only. So how much speeder it was there? Observe here, almost equal to 2 times faster. So I will take one other example. So I am taking now 8 instructions. Observe here, I am giving the complete explanation with this very good example. 8 instructions I am going to be execute with a 4-stage pipeline. Observe here, right now I am drawing this time diagram. So through this only I am going to be explained. So this is the clock cycles of the time. How much time we are executing. This is the stages. Instruction fetch phase, this is decoding phase, this is execution phase, this is write back phase. So here in this, first instruction 1 coming to fetching phase. Okay. So remaining all are empty. All stages are empty, not doing anything. So in the first clock cycle time, next second clock cycle time, I1 is came to the decoding phase. I2 at the same clock cycle of time, second clock cycle of time, I2 is coming into the instruction fetching phase. Next, what will happen in the third clock cycles of time? I1 will come into the execution phase, I2 will come to the decoding phase, I3. Now I3 is also come to the fetching phase. Next, fourth clock cycle of time, I1 will come to the write back, I2 will come to the execution, I3 will come to the decoding, I4 will come to the fetching phase. Next, at this time, the instruction 1 is executed at fourth clock cycles of time. Next, in the fifth clock cycle of time, I2 will come to the write back, I3 will come to the execution, I4 will come to the decoding, I4 will come the fetching. Next, instruction 2 is executed and write back to the memory. Now, I3 will come to the write back, I4 will come to the execution, I5 will come to the decoding, I6 will come to the fetching phase. This is at sixth clock cycles of time. So, I3 execution is also completed. Right now, the I4 will come to the write back, I5 will come to the execution, I6 will come to the decoding, I7 will come to the execution. Next, fetching. Next, I5, I6, I7, I8. Now, at the 8th clock cycles of time, all instructions are entered into our pipeline. Now, I5 will execute at the 8th clock cycles of the time, and 9th clock cycles of time I6 will execute, and 10th clock cycles of time I7 will execute, and 11th clock cycles of time I8 will execute. So within 11 clock cycles of the time itself only, the entire the 11 clock cycles of the time, the entire all 8 instructions are executed. So while coming to this execution of these 8 instructions in the non-pipeline, how much time it is going to take? Observe here, 8 with 4 stages, 32 clock cycles of the time. 32 clock cycles of the time it is taken, but while coming to here, 4 stage plus n minus 1, 8 minus 1, 7. So 4 plus 7 is equal to 11. So observe here, so with non-pipelining, we are taking the 32 clock cycles of time. In the pipelining, we are got the only with 11 clock cycles of time. So how the huge difference it was there. If you observe the speed up, if you calculate the speed up here, going with now how much speed it is taking, non-pipelining by pipelining. So non-pipelining it has the 32, in the pipelining it has almost 3 times, equality 3 times faster than non-pipelining. So this is the beauty of the pipelining concept. Because of this pipelining, the completely 3 times the execution is faster than the non-pipelining. Next. So what are the so this is the complete explanation, the concept and workflow of the pipelining. Now the advantages of this pipelining, it leads to the higher instruction throughput and efficient CPU utilization. Efficient CPU utilization means parallelly execution of all instruction. It leads to more CPU utilization only. It will automatically give the performance improvement. So faster executions. Next, disadvantages. But for making of this pipelining, the complexity of we can face at the hardware level only. While designing of this hardware, we can face the problem, and hazards also. Why hazard? Instruction 1, it is depend R1 is R2, R3 is equal to R1 plus R2, and instruction 2 is R4 is equal to R3 plus R5. For example, this R3 is depending on the instruction 1. This once get this instruction 1 execution result, then only the instruction 2 is going to be executed. For example, if the delay happens at this instruction 1 execution, automatically instruction 2 execution will be delay. So it means it will lead to the pipeline hazards. So we need to focus about the pipeline hazards effectively, and then to achieve the better performance. It is the very good, very challenging things while implementation of the pipelining. So because of that, automatically cost is going to increase, and the performance affected by the halts and by the stalls itself only. Okay, so this is the about complete explanation of the instruction pipelining. So in not only in this pipelining process, instruction pipelining I explained, and then we can have the arithmetic pipelining and processor pipelining also. These are the main 3 pipelining types we can use based on the requirement, based on the usage in the system. So here, especially in this instruction pipeline, whatever I told, whatever I discussed here is completely based on the stages only. So I used a 4-stage pipeline here, and based on that, I calculated the speed up, I calculated the efficiency, and I explained by comparing with the pipeline, non-pipelining, and how the pipelining is faster, almost 3 times faster. For example, one more for the speed up purpose, I am going to tell you one thing. Finally, I have that 1000 instructions. 1000 instructions means in the non-pipelining, how much time it is going to take for the 4 stages, for the 4 stages, for almost 4000 in such 4000 clock cycles of the time it is going to take. But while coming to this pipelining, we can go with the k plus n minus 1. So k plus n minus 1 means 4 plus 1000 minus 1. So 999 plus 4. 999 plus 4 means almost 1003. So 1003 cycles only we are completing. So how much time it is going to be faster? Almost 4 times it is the faster. So 4 times faster. And here one more point you people has to be remember, this one instruction while implementing this pipeline, one single kind of conclusion, that is each instruction will take only 1 unit of the time only. That is the main goal for the pipeline. Okay. So this is with the help of this pipelining and stages, we are effectively implementing parallel processing, and we are executing all the instructions concurrently. So thank you so much.